Okay, so this video is an example of doing windowing for FIR filter design. And what we want to do in this example is to design a 5-tap low-pass filter with a cutoff frequency of pi over 2 using a Blackman window. Now, of course, we recall the obvious, which is that an FIR filter is designed as h of n, which is equal to omega c over pi times the sinc of omega c times n minus x, where x is equal to m minus 1 over 2. And m is my number of taps, so this is equal to 4 over 2, which is equal to 2. So first thing we do is we calculate the filter, and we also need to know what is the value of the Blackman window at each of these points. So let's look first of all at WBL of n for each of the points. So WBL of 0 is going to equal to, if I come back and take a look up here, it's going to be equal to 0.42. All right, it's going to equal to 0.42 minus 0.5 times the cosine of 2 pi n over 4. So times the cosine of 2 pi times 0 divided by 4, and plus 0.08 cosine of 4 pi times 0 over 4. All right, so cosine of 0 is 1 in both cases, so in this case it's equal to 0.42 minus 0.5 plus 0.08, which is equal to 0. So that means that h of 0 is equal to h, and I'm going to put a prime to denote that I've windowed, is equal to h of 4 is equal to 0. Because if I multiply any tap weight by 0, I'm absolutely going to get 0. So this first one is done. All right, next up, let's look at WBL of 1. And that's equal to 0.42 minus 0.5 times the cosine of 2 pi times 1 over 4, which is pi over 2, plus 0.08 cosine of 4 pi over 4, so which is just cosine of pi. All right, so this one here becomes a minus 1. This one becomes a 0. So I'm going to have 0.42 minus 0.08, which is equal to 0.34. All right, and then what I would do is I would multiply that by h at that point. So it's going to be h prime of 1 is equal to h prime of 3, which is equal to 1/2 sinc of minus pi over 2 times 0.34, which is equal to 0.108. All right, and then lastly I have to do h prime of 2, and in this case I'm going to take 1/2 times the sinc of 0 times, and then in this case I'm going to get 0.42 minus 0.5, and then this is going to be cosine of pi plus 0.08 cosine of 2 pi, which gives me just 1/2. All right, so that is the full solution to this problem. It's really not that complicated. All I need to do is to find the windowing values and multiply those by the filter tap weights.